Have you always thought that 3D printed parts are flimsy and break just too easily? Yeah, they do, sometimes. But luckily, 3D printers today are capable of a whole lot more if you pick the right technology and material. You can create high-quality, long-lasting end-use parts for a wide range of applications. Not only that, you can do it quickly and cost-effectively on a compact 3D printer from your office, workshop, or manufacturing facility. In this video, we'll showcase materials offered by the most common 3D printing technologies for plastics: fused deposition modeling, or FDM, stereolithography, or SLA, and selective laser sintering, or SLS. We'll compare functional and material properties, visual characteristics, and show you a framework that you can use to find the best match for your project. Let's start with FDM 3D printers. FDM 3D printers melt and extrude thermoplastic filaments, which a printer nozzle deposits layer by layer in the build area. The most popular FDM 3D printing materials are PLA, ABS, and their various blends. PLA is ideal for printing concept models and looks like prototypes in a variety of colors, but it tends to be quite brittle. ABS is a tough and durable as well as a heat and impact resistant alternative, but is also generally harder to print with and requires ventilation. Between the two, PETG offers a good mix of properties, easier workflow, and can also be semi-transparent. If you're looking to print flexible, stretchable parts, TPU is a great choice for printing simple designs. Most advanced FDM printers can also print with engineering plastics like nylon and specialized composites like carbon fiber-filled plastics. Next, let's talk about SLA 3D printers, or resin 3D printers. SLA 3D printers use a laser to cure thermosetting resins into hardened plastic in a process called photopolymerization. Formlabs SLA 3D printers are highly versatile, offering a wide variety of resin formulations. Standard resins are ideal for printing high-resolution models and prototypes with a smooth surface finish. Draft resin can print parts faster than any other technology, while resin printing is also the only 3D printing process that can create truly clear and transparent parts. For engineering applications, there's a variety of strong, robust, and functional materials with properties similar to ABS, PP, and other common plastics. There are also glass-filled materials for rigid and exceptionally stiff parts, offering heat resistance to more than 200 degrees Celsius for advanced applications like molding. Flexible and elastic resins are available to create parts with the flexibility of rubber, TPU, or silicone. For specialized applications, there's a wide range of biocompatible medical and dental resins, as well as jewelry resins for investment casting. Lastly, polyurethane resins are production-grade, rigid, and elastomeric materials for durable, long-lasting end-use parts. Now, let's look at SLS, or powder 3D printers. SLS 3D printers use a high-powered laser to fuse small particles of thermoplastic powder. Formlabs SLS 3D printers offer materials with excellent mechanical characteristics resembling injection molded parts. The most common SLS 3D printing material is nylon, a popular engineering thermoplastic that is lightweight, strong, and flexible, as well as stable against impact, chemicals, heat, UV light, water, and dirt. Nylon 12 powder is the most commonly used SLS material that is ideal for functional prototyping and end-use production of complex assemblies and durable parts with high environmental stability. Nylon 11 is a higher performance material that offers similar properties to Nylon 12, just with higher elasticity, elongation at break, and impact resistance, but lower stiffness. Nylon can also be reinforced with other materials to boost its performance, such as glass for rigidity or carbon fiber for lightweight and strength. Beyond nylon, SLS printers can also create flexible TPU parts with unmatched design freedom and ease. TPU is an elastomeric material balancing high elongation at break and superior tear strength that is ideal for functional prototypes and end-use parts. With all these 3D printing materials available, are you wondering which one is right for you? Here's our 3-step framework to choose the right 3D printing material for your application. First, define your performance requirements. Plastics used for 3D printing have different chemical, optical, mechanical, and thermal characteristics that determine how your 3D printed parts will perform. For form and fit prototyping and models, start with FDM printing and PLA, or use SLA printing with standard, clear, or draft resins for higher quality parts and for more complex designs. For functional prototyping, choose FDM printing with ABS or TPU, SLA printing with an engineering resin best suited for your application, or SLS printing with any material for the strongest parts. For end-use parts and industry-specific applications, we recommend composites on FDM, a wide range of specialized materials, or polyurethanes on SLA or any SLS 3D printing material. Once you've identified the performance requirements for your product, the next step is translating them into material requirements, or the properties of a material that will satisfy those performance needs. You'll typically find these metrics on a materials datasheet, which you can compare with the specs of materials produced by traditional manufacturing processes. In the end, you'll most likely end up with a single material or a smaller group of materials that could be suitable for your application. If there are multiple materials that fulfill your basic requirements, you can refine your preferences further by looking at a wider range of desired characteristics, such as workflow requirements and price, to find the 3D printing material that's perfect for you. Subscribe to our channel for more 3D printing videos, and check out the links in the description to learn more about Formlabs 3D printers and our range of over 40 3D printing materials.